Hello, my name is Jonathan Cox and I am presenting our work AGRIDS for an integrated framework for Vineyard data management and robotic deployment. Our aim is to create a comprehensive Vineyard map that goes beyond simple spatial representation. We aim to capture not only the spatial layout of the vineyard, but we also want to store semantic and temporal information associated with its features. These are some of the features we want to capture on our map. So for example, the map should not only identify a line as a vine row, but it should also specify the variety and the planting date. The map should be dynamic, reflecting changes in yield, vine growth and other factors over time. And our second aim is to aid and speed up the deployment of robots in vineyards. So why do we want to do this? Over recent years, the use of robotics and precision agriculture has increased, and both rely on accurate and timely data. Unfortunately, current software and data management practices in agriculture are fragmented, lacking the standardization found in robotics, such as the ROS framework. This fragmented landscape leads to inefficiencies such as redundant data entry and difficulties in data sharing. One piece of software will do one or a few tasks, but the grower will also need to use other pieces of software to manage their vineyard data. This is our proposed solution, AGRIDS, which stands for Agricultural Robotics Integrated Data Storage. It is a system that integrates data from diverse sources, including robotic sensors, static sensors, and UAVs. By combining technologies from both robotics and agriculture, we can create a unified platform for managing spatial, semantic, and temporal data. This image illustrates the structure of a vineyard, which forms the foundation of our model. The structure enables us to manage data and analyze data at different levels of granularity, from the entire vineyard down to individual vines. So our aim is to help growers make more informed decisions about their crops. This diagram illustrates the core components of AGRIDS and how they interact. The central hub is Firewire Orion, which is a context broker and manages and processes real-time data. Cygnus handles long-term data storage of historical data. Both of these store data in a MongoDB database where structured vineyard data is stored, such as the poles and the vines. MinIO is an object storage system for unstructured sensor data, such as images and point clouds. We use Zeno for communication protocol for data exchange between the robot and the rest of the system. The contextual tagging software takes the sensor data and stores the data in MinIO and stores a reference to this data with the relevant vineyard feature in Orion. So for example, if an image from a robot was received, this section will calculate what vine the image was taken of and store that image in the system along with a reference to the vine. And finally, a front end to interface with the system. This table shows the data structure stored in Orion in AGRIDS. As I said before, we divide the vineyard into blocks, rows and vines. We also have polygons, lines and points to add other features to the map, such as buildings, water pipes. To interact with the system, we use Orion's REST API for creating, reading, updating and deleting entries. So how can this help growers? It saves time. Once they have their data in the system, they can have a centralized view of it. There's no more repetitive data entry into different platforms, as they can export their data to the other platforms. They have a more detailed view of the vineyard and can make improved decisions about management of their vineyard, ultimately saving time and costs by optimizing resources. The screenshot here is an image of our prototype front end, which is a Flask app. It shows a map of the vineyard. The different features are highlighted and the block and vine data is shown in the table below. So our AGRIDS can not only help growers, but can also help external service providers. So AGRIDS provides a single source of truth for agricultural data, streamlining data access and integration. So instead of the grower or the service provider entering the same data in different platforms, the data only needs to be entered once and everyone has access to the same data. If the data is updated, anyone can access the same data rather than different companies having outdated data. By reducing the need for data collection and processing, this system can help service providers optimize their operations and reduce costs. An example use case of this is deploying a ground robot to collect data of a vineyard. Normally, before robots can autonomously navigate around an environment, accurate and up-to-date maps are needed. Currently, this is a very time-consuming process involving a manual teleoperation of the robot around the environment. AGRIDS offers a more efficient solution by automatically generating maps using vine row data. This significantly reduces the time required for robot deployment and improves overall efficiency. We successfully tested this approach in our experimental vineyard. We have tested both methods of recording post locations from an RTK GPS device and from UAV images and using object detection to extract the post locations. These post locations are imported into AGRIDS where they are connected into vine rows, and from these posts and row locations a navigation map can be generated for the robot. This video shows the robot autonomously navigating around the vineyard. No robot has ever been in this vineyard before. For our small vineyard, which is around 600 square metres, the current method of manually driving the robot around to create the map takes around 20 minutes. Our method of flying a UAV and detecting the post using object detection takes around 5 minutes. For larger vineyards, this time saving would be much greater. For our future work, we want to extend beyond maps and support advanced agricultural applications. For instance, we can use the platform for yield estimation by integrating external image analysis tools. The image analysis tools may want the image of the vines and the varieties and other data to make an estimate of yield. You can retrieve this data from AGRIDS, estimate the yield, and store the yield data with the vines back in the map. This allows for a more automated process, replacing the traditional labour-intensive methods. By generating yield maps, growers can then make more informed decisions and improve their vineyard management. Thank you for listening.